Okay, so we're going to have a look at the first couple of examples. They're very straightforward. They're basically just asking you to switch between radians and degrees, and this is something you need to get quite proficient at doing because you have to do it a lot, because sometimes questions give you them in one unit and not the other, and sometimes it's necessary to move yourself into radians for a variety of reasons. So it says convert the following angles into degrees. It's really straightforward, but I just want to remind you of a basic kind of currency conversion thing, which is that if I have, say, X amount in pounds is equal to Y amount in dollars, then I can convert between the two by remembering that actually there's a ratio thing going on here. So if X pounds is Y dollars, I can divide both sides by X and realise that £1 is equal to Y over X dollars. So if I want to convert any amount of pounds into dollars, I can just multiply by Y over X. And in exactly the same way, if I go the other way, $1 is equal to X divided by Y pounds, which means if I know the amount of dollars, I can just multiply by X over Y. This is a really standard bit of currency conversion. In fact, it's just a ratio problem. Divide by the amount you have and multiply by the amount you want, and you'll land on the right amount. And then the next thing to note is what we have is exactly the same situation. We know that pi radians is the same thing as 180 degrees because we've established that already. That's by definition of a radian. So if I want to convert 7 pi over 8 radians into degrees, what I actually want to do is I want to do 7 pi over 8 divided by pi and then multiplied by 180, or as just a shortcut, you multiply it by 180 over pi. Okay, and that's it. That's all we have to do. So on the calculator, 7 pi over 8 multiplied by 180 over pi. Hit equals, get 315 over 2. Now, fractions aren't actually terribly useful when we're in degrees, so let's convert it to 157.5 degrees. Second question is exactly the same. 4 pi over 15 multiplied by 180 over pi is now actually I can because I'm paying attention, I can shortcut this slightly. I can just ignore the pi because I've got a pi on the top of this fraction and I've got a pi down the bottom here. They're going to cross cancel, so this is actually just 4/15 times 180. The pi's already sorted themselves out, and I get 48 degrees. Done. Dead simple. Now you can also do this directly on the calculator. You don't have to memorize this conversion. The calculator will do it for you, and this is how you do it. On the calculator, there is an options button right here, and that gives you 3 options. And the one we care about is 2, the angle unit. So if you press option and then 2, you get this list of 3 different angle units: degrees, radians, and one we don't care about called gradians. And what we do is we just press 1 and we get this little degrees symbol in here. Now it's got an error because it doesn't know what I'm on about. But if I type in 30 first and then say options angle units 1, 30 degrees, and the calculator goes, oh, I recognize 30 degrees, that's just, well, it's 30 degrees. But if I give it something in radians, like for example pi radians, so I need to tell it this is in radians. So options 2 for angle unit and then 2 for radians. I get this little R symbol, which just short for radians. Pi radians, hit equals, and it says, I know pi radians, that's 180 degrees. Dead simple. Which means I can do the same thing for this. So if I type in 7 pi over 8, and instead of doing the multiplication myself, I just press options, angle unit, radians, I'm saying to the calculator, this is a measurement in radians, tell me what it is in degrees, and it tells me 157.5 degrees. No problem. This is working because the calculator is currently set up in degrees mode. So any answer you give it, it will turn into degrees if it recognizes we're dealing with angles. So if you tell it an angle in radians, it will turn that angle into degrees for you automatically. The problem is, that is example 1. Example 2 is the other direction. So by hand, this is fine. 150 degrees. Well, as I said a second ago, to convert that into radians, I need to divide by 180 and multiply by pi. I need to do it the other way around. So that's fine. I just need to do 150 multiplied by, and then pi over 180, and I get 5/6 pi. Or, if you prefer, 5 pi over 6. Same thing. And the second one is exactly the same. 110 multiplied by pi over 180, and I get 11 over 18 pi. So 110 degrees is 11 over 18 pi, and these are both answers in radians. The way you write your fraction doesn't actually matter. Pi can sit on top or next to, makes no difference really. If I want to do that in the calculator though, it's a little awkward, because if I type in 150 options angle units degrees, the calculator says, well, yes, I know 150 degrees is 150 degrees. Its target unit is degrees, so it's not going to do anything useful for you. So we have to ask the whole calculator to give us answers in a different angle unit. And you do that by hitting Shift and then Menu Setup. So we have all these, we've got loads of setup options in here. It's actually the very top menu option you want, and the second one, angle unit. If I press that, I get the 3 different angle units, degrees, radians, and gradians that we don't care about. The default for these calculators is to work in degrees all the time, but we want to work in radians now. So I'm going to press 2, get radians, and right at the top of the calculator screen, there was a little letter D, and now there's a little letter R next to it. So the whole calculator is now working in radians, which means if I type in 150 degrees now and press equals, it tells me what that is in radians instead. So you can do all of this converting in and out of radians and degrees exclusively on the calculator. I don't think it's a big deal to remember that 1 pi radians is 180 degrees. That's straightforward, and that makes the calculation easy. But you can also make the calculator do the whole thing for you if you know how to switch the calculator into the correct mode and remember how to access those degree and radian symbols to say, this angle I'm giving you is in radians, tell me the answer in degrees, or vice versa. It's actually really common for people to have calculators in the wrong mode for all of these angle type questions, in particular for trigonometry. So it's well worth knowing how to change that anyway. And in fact, it will be necessary for you to turn your calculator into radians later on during the year. Graphical calculators often default to radians, not degrees. They still have the same menu options to switch between them, but whereas the scientific ones, like the class widths, tend to be in degrees by default, graphical ones tend to be in radians by default. So you need to just pay a bit of attention to which your calculator is in. I know that a number of students I've taught in the past have by habit had their graphical calculator in radians, their scientific in degrees, and then they just pick the one they need depending on the calculation they're doing, and they have both calculators available to them during tests. It is entirely up to you how you manage it, as long as you pay attention to your calculator's mode. One final little thing before we move on. There are a handful of key conversions which will make your life a whole load easier if you just learn to recognize instead of relying on the calculator. So we already know that 360 degrees is 2 pi radians. And we also know that 180 degrees is pi radians. And as a consequence of those, 90 degrees is pretty straightforward. It's pi over 2 radians. All of those are kind of givens and pretty straightforward based on the conversion between degrees and radians and what we know about radians. But there are a handful of other angles which is really important that you pay some attention to. Notably, they're the ones that give nice exact values to the trig functions. Ones we talked about plenty in year 12, ones most of you will have met in year 11 or year 10 at GCSE. So the other angles that matter are 60 and 45 and 30. Okay, so these in degrees, we just need to have in our heads that they're easy to put into radians as well. If 90 degrees is pi over 2 radians, 45 degrees means I have to halve it again. So it's going to be pi over 4 radians. Straightforward. If 180 degrees is pi radians, 60 degrees is 1/3 of that, so it's going to be pi over 3 radians. And 30 is half of that 60, so if we halve that, we're going to get pi over 6 radians. It would be really sensible to spend a bit of time getting familiar with those, because just like when you see a question with 60 degrees in or 30 degrees and you go, oh yeah, that'll have surds in, that'll be exact. The same thing is true when you're dealing with radians. You should spot pi over 3 and go, oh yes, that's one of those exact surd answers. It will probably be nice and neat and tidy. And in reverse, if you see a nice neat surd, you can have in your head that is likely to land on one of these nice fractions of pi over 2, 3, 4 or 6. It is likely to be one of those because it looks like a nice surd answer. And the textbook actually has a nice summary of these in the middle of these examples. They're not hard to figure out. I wouldn't even suggest you need to memorize them, because as long as you know pi is 180 degrees, you can find them quite quickly, but you should recognize that they are special, and therefore you can tend to do these questions involving these quicker, and you certainly don't need to be pulling your calculator out to convert these ones.